My name is Durgesh, and I am a software person and also a part-time teacher. So let me start with the topic. So what I'm going to give a demo is on the squares as well as the square roots. And we will start with the square numbers. Then we will try to understand what are square roots. And after discussing both the concept, we will look at the real world examples. And at last, I will discuss few examples on perfect square numbers. So let's get started. So let me talk about the square numbers. Just a minute. So as the name says, square in mathematics, what the square numbers means is if I have a similar numbers and if I multiply them, then the result will be a square number. Suppose if I multiply 2 with 2, we get 4. So 4 will be a square number. Similarly, if I multiply 3 with 3, we get 9. So 9 will be a square number. So if I generalize my definition, we can say that if I multiply two numbers n with n and we get m, we get m. So therefore m will be a square number. So if I solve this equation, we can say that m is equal to n to the power 2. So m will be square of n. Now what we can do is we can take the square, or we can say that n is equal to m to the power 1 upon 2.
Sir, click on the board. We can't see it.
Okay, okay. Where's the board, sir? Okay.
The
Hello.
plus sign top of it. So the left hand side plus sign.
See, I am everything I am doing on the board only.
Yeah. Wait, just a second.
Yeah.
Okay, got it. Got it. Continue.
Okay. So shall I go ahead or shall I restart?
Okay, you restart. It would be better, sir.
So I'm just refreshing everything now.
I will
Okay.
cross that and then.
Okay. Just a minute, sir. So I was getting your calls. I just cut it.
Okay.
Let me check. Okay.
Huh.
So I'm restarting from the scratch.
Yeah.
What I'm going to discuss. So my about square numbers as well as square roots, and that we will discuss in the later part of the session. So let's talk about square numbers. Suppose if I multiply two similar numbers, then we get a square number. Now let's take the example of 2. If I multiply 2 with 2, we get 4. So 4 will be a square number. The other example of square number can be if I multiply 3 with 3, we get 9. So 9 will be a square number. So if I generalize my definition, suppose my number is n, and if I multiply with n itself, we get m. So m will be a square number, and we can also say that m is equal to n to the power 2. We get 2 if we follow the law of exponents. We just add the powers. Okay. So let's give this as equation number 1. Now, on the reverse side, we can also say that n is equal to m to the power 1 upon 2. So any number to the power 1 upon 2 means square root of that number. So here we can say that n is actually square root of m. So if I use the radical sign for square root, you can say that n is equal to m, and this is a sign for square root. This is a radical sign. Let's give this as equation number 2. Now, let's go back to the similar example from where we started. Using the example and using the equation number 1, we can say that 4 is equal to 2 square. And using the equation number 2, we can say that 2 is equal to square root of 4. Now, let me give a definition to this. If 2 is the square root of 4, then I can say that 4 is the square of 2. Is it correct? Now, let's give the definition in generalized form. If I say that n is the square root of m, then we can also say that m is the square of n. So this is a very important part that you need to remember, and when we go to the square root calculation, we will discuss this in more details. Now let's start with an example here, and where we'll discuss both the application. Okay, so let me pick an image here. Okay, so here you can see like there is an image, and let me explain you the problem statement here. Suppose there is a residential place, and assume that it's a residential place. Now there are some arrangement of houses, and the houses are arranged in such a form that there are equal number of rows as well as columns. Assume that there are 50 rows as well as 50 columns. Now, a newspaper hawker wants to distribute newspapers at each and every house, but he doesn't know how many newspapers he should carry so that he can he can communicate, or he can reach every house. So he wants to know how many newspapers are required. So let's try to help him with that. As we know that there are 50 rows as well as 50 columns, means I can say that if I take one row, I can have 50 number of houses. Now if I take all 50 rows, then how many houses will be there? Yes, it will be 50 times 50. And what is 50 times 50? It is equal to 50 square, or if I solve this, I can tell that 50 square is 2500. So there are 2500 newspapers he needs to carry, or there are 25 number of houses there. Let's go back to 2500 and let's see the what is 50 square. 50, what is 50? If you see 50, it is actually the total number of rows as well as the total number of columns. Means if I have an arrangement of object in such a way that the total number of rows and the total number of columns are equal, then squaring either row or column will give me the total number of objects. So instead of houses, you might have the people standing in 50 rows or 50 columns, or there can be 70 rows or 70 columns where you have some arrangement of people. So you just need to take square. This is how taking square will help you in solving your problems. Now let's go ahead and try to look at one more problem here. Okay, let me maximize the image. Okay, so let me describe you what the problem says. See, suppose I have some number of houses. Suppose these are the number of houses, and there is some construction company. Now the construction company wants to create these number of houses in such that they are or they will occupy equal number of rows as well as equal number of columns. And suppose the total number of houses are 2500, and what the problem statement says that we have to find the total number of rows as well as the total number of columns. So let's try to find how the arrangement is to be done. Suppose that there are n number of rows as well as n number of columns. Means if I take one row, there will be n number of houses. Now if I take all rows, so the total number of rows are n. If I take all n rows, the total number of houses will be n times n, which is equal to n square. Now if we go back to the problem, the total number of houses that needs to be constructed are 2500. So I can equate n square to 2500. So if we solve this, we can say that n is equal to either plus 50 or minus 50. But in the real world, we know that minus 50 is, or if we count something, negative number is not applicable. So we can cross it. So our total number of rows will be 50. Means what we have done is, to get our answer, we have just take the square root of the total number of objects. It means that if some count is given or the objects are given, and we have to find how the things are to be arranged, taking the square root will provide us the correct and the better result. So this is how I will end my demo here, and thank you so much.